What's this, some new kind of dance? Nope, it's America's newest sport, and it's called skateboarding.
Oh my gosh, hey, didn't see you there. Well, since you're here, let me explain to you the physics behind skateboarding. The first trick we're going to be looking at is the hippie jump. Before we look at the physics involved, let's watch the trick. Now we're going to slow it down just a little bit. There is no velocity in the y direction, but there is velocity in the x direction, and this velocity is the same for both the rider and the skateboard. When preparing for the jump, the rider applies a force downward onto the board to propel himself up and over the bar. This can often prove as difficult because if the rider applies a force in the y direction, either way, the board will be forced in the opposite direction due to the conservation of momentum. This means the jump cannot be complete. Due to their small value, both air resistance and friction are negligible. This means that the rider and the skateboard continue to travel at the same velocity. The force of gravity acts on the rider to pull him back to the board, and his motion follows that of a parabolic arc that resembles very closely to a projectile. The rider then safely lands on the board. Key concepts from this trick include conservation of momentum and projectile motion. Now we get to talk about arguably the most fundamental trick in skateboarding, the ollie.
Hey, that's not a poser, that's an expert.
So let's break it down. The skater begins in a crouched position and applies a downward force on the board. This force of the feet on the board is represented by red arrows. As we know that for every force there is an equal and opposite force, the blue arrows represent the force of the ground on the board. The green arrow represents the force of gravity on the board and the skater. In stage 2 of the ollie, the rider slides one foot up the board, creating a parallel force to the board that both helps to lift and guide the board along with the foot in the air. With his other foot, he pushes down on the tail end of the board. This creates a very strong impulse force that helps the board rebound off of the ground and lift it up in the air. Stage 3 of the ollie, there's very little force applied, but there continues to be the parallel and perpendicular force that helps guide the board along with the feet. Now both the force of the feet on the board and the force of gravity help to bring both the rider and the board back to the ground. Key concepts of this trick include balance forces and Newton's third law. Now we get to examine the front side 180. The most significant concept for this trick is the conservation of angular momentum. This means that the angular momentum of the upper body and the lower body have the same magnitude but opposite direction. This means that they add together to equal 0. If we examine the following clip, we are able to see that the skater's lower body is moving in a clockwise direction, while his upper body is moving in a counterclockwise direction. This trick is achieved through increasing rotational inertia by the movement of his arms during the jump, and using torque when hitting the ground to rotate upper body back to its normal position. Key concepts include conservation of angular momentum, rotational inertia, angular velocity, and torque. The final trick we will be looking at is pumping the half pipe. Even though this trick doesn't look very impressive, it allows the skater to increase speed without pushing off the ground. This allows for higher speeds and getting greater height when exiting the half pipe for larger tricks. This trick can be explained using angular impulse and momentum, however, it is more simply explained using work and energy. The centripetal force caused by the circular shape of the half pipe makes it difficult for a skater to raise their body and arms upon exiting the half pipe. This is because the centripetal force pushes their body away from the center of rotation, or point O as depicted in the photo. The net work that is performed by moving against the centripetal force is equal to the net energy gain of the system. This means that the energy increase is what results in a faster speed that pumping the halfpipe provides for the riders. The key concepts behind this trick are angular impulse and momentum, work and energy, and centripetal force. Thanks for listening, everyone, and I hope you enjoyed this video on the physics behind skateboarding.